Alright guys, we're starting the day a little bit late. What can I say? It's 5 p.m. right now. But I had to do quite a few miscellaneous tasks today. And I finally have the time just to work on some of the stuff that I need to get done. It's good that I've touched quite a lot of these. You know, at the end of the day, I also have 4 more things to touch up on, which is cool and all. And I think I just need to do more of these, I guess, backtracking problems first. And this heap priority queue, I could do it right now to design Twitter, get it over and done with, for sure. But no, today I had this 2 suitcases that I bought that finally arrived, and I have them at home set up in the way that I kind of want it. And I also had to go to a doctor's appointment, which I'm back from now. They told me, unsurprisingly, that I have a vitamin D deficiency, so I literally have to touch more grass at some point in my life, and ideally soon. Hello Aryan, hello. Nice of you to be the first to join and chat, you know, so welcome. Yeah, I know you were there yesterday. No. Oh, that's my bad. Got a bit of a motivation watching you to get started with my work also. Alright, yeah. That's it. That's exactly what I'm here for. You know what I mean? Alright, so what is this? I'm guessing this is, yes, we are live now. We will start Obsidian and doing just one of these Leetcode questions, and hopefully we don't spend too long on this either, because let's cap it at most 40 minutes. I reckon that would be the idea, and the ideal amount of time. Ideally, I would also like this to be done in less than that. So design Twitter feed. This is going to be a heap queue problem. We want to implement a simple version of Twitter which allows users to post tweets, follow, unfollow, and view the 10 most recent tweets within their own news feeds. Users and tweets are uniquely identified by their IDs. Implement the following methods. Twitter to initialize the Twitter object. Void post tweet ID and tweet ID. Publish a new tweet with ID, tweet ID by the user ID. You may assume that each tweet ID is unique. The list integer Get newsfeed for the user ID fetches at most the 10 most recent tweet IDs in the user's newsfeed. Each item must be posted by users who the user is following or by the user themselves. Tweet IDs should be ordered from most recent to least recent. Ordered from most recent to least recent. And follow the user with ID, follow ID, follows the user with ID, followee ID. Followee, follower. And the void to unfollow the user with ID unfollows the user with ID. So follow and unfollow is going to be interesting. You could keep it in a set, I suppose, but does it really matter beyond that? And how would a heap queue actually work here? Because, you know, get newsfeed, maybe that's your heap. 10 most recent tweets, right? That makes sense. And post tweet adds the most recent to the top of the heap. And that would mean that you get that's fine. But, you know, it's still interesting because what happens to get newsfeed? So there's no delete object here, right? Right, so let's have a look, right? 10, 20, 2010, 2010. Wow. Post tweet 110, 210, user 1, user 2. Get newsfeed for user 1, it'll just be 10. Get newsfeed for user 2, it'll just show 20. Now what, you keep two heaps for each person? No, you can't really feasibly do that. When you follow, when one follows 2, get newsfeed 1 means you get 20 and 10. And get newsfeed 2, you still get 20. When you unfollow 1 and 2, you still should get just 10. Okay, so this is going to be tough because how can you design something like this? Because I think, you know, you're going to have a heap for sure, but how do you use this heap in a way that's the way they want? I can't think of a way. So we will look at the solutions. Heap properties, heap usage, heap push and pop. Okay, well, let's see.
Hey everyone, welcome back and let's write some more Leetcode today. So today let's solve the problem design Twitter. This is a somewhat challenging problem for a medium, and spoiler alert, this is actually really similar to another Leetcode problem which is called merge k sorted lists.
Yeah, merge k sorted lists. Is this? No, I haven't done merge k sorted lists before.
And that problem is actually a hard problem, so it's kind of weird that they make this a medium problem because this problem is actually even harder than the merge k sorted lists problem, but that's okay. So we are told to design a simplified version of Twitter, and this problem is really about which data structures are we going to use for each of these functions. So you really need to have an understanding of trade-offs to make sure that we implement each of these functions in the most efficient way. So there's in total 5 functions we want to do. One is the constructor, so that's where we're really just going to handle what data structures we want to use, like initializing them and all of that. And I'm actually going to start with the implementation for these 2 functions, the follow function and the unfollow function. So any user, in this case, the follower ID is the user, can follow another user, and that's called the followee ID, followee. A little bit confusing for me. But so clearly with this function, we need to keep track that this user is following this user, right? We need a data structure to do that. Now there's a bunch that we could do. The easiest one that you might consider is a map, right? We want to map this user to another user. But of course, a user can actually not just follow one person, but they could follow multiple people. So the simplest idea that you might think of is first, okay, create a hash map, right? Where we're going to map the user ID, right? Just some generic user to whoever they're following, right? We'll call that the followee ID. But it's not just going to be one, so let's actually call it list of followee IDs, right? That's just our naive approach. That's just the first thing that came to our mind. So if each time we get a user and we are told that they follow somebody else, we can just keep adding that, user that they follow to the end of that list that we have, right, in our hash map. This is going to be the key. This is going to be the key is going to map to a list, and we can add a new value to that list in O of 1 time. So that's easy. But now we're introducing a second operation called unfollow. So if a user now wants to unfollow another user, how can we implement it with our current data structure? Well, removing from a list is not as easy as adding to the end of that list, because we might actually have to search through the entire list to even find that followee ID that we're trying to remove, and then removing it is going to be a big O of n time operation. Is there a more efficient way that we can do this? Well, there is a data structure we know that can add and remove in O of 1 time. Do you know what it is? Well, hash map is one of them, but in this case, we don't really need a map. We just need a set of values, right? A list or a set. But in this case, we can use a hash set, and that can insert and remove in big O of 1 time. So instead of using a list, which was our naive approach, we're actually going to map each user ID to a hash set of followee IDs. Okay, so that's actually pretty easy, right? So we've already figured out follow, and we've already figured out unfollow. And of course, we're going to be initializing this data structure inside of our constructor. But now for the somewhat difficult part, the post tweet and the get news feed function. So let's start with post tweet. Each user can post a tweet, and obviously they can post more than one tweet. So we need to be able to map a user to their list of tweets, right? Let's just start with a list again and see if it works out for us. So again, we're going to have a hash map. Okay, so we're going to have another hash map mapping each user ID to the list of their tweets. And each time we post a tweet for a given user, we're just going to take that tweet and add it to the end of that list. So let's just see if that works for now. That's like the most naive approach. And in this case, I'll just tell you it is going to work for us, and you're going to see why. So by the way, this post tweet, if we're just adding to the end of the list each time, we can do that in big O of 1 time. So we've basically got all three of these functions running in big O of 1 time, but this get news feed is going to be by far the most complex function. So basically, for any given user, we want to retrieve the 10 most recent tweet IDs for that user. And the way we're going to get the 10 most recent tweets is from the list of followees, the list of people that user follows, right? And from that list of people that they follow, we want the 10 most recent tweets. Now, how do we even get most recent? Well, one, anytime a user posts a tweet, we're already adding it to the end of the list, right? So if we create a list of tweets, right? Let's say this is the first tweet, then we have the second tweet, then we have the third tweet. Of course, the most recent tweet is going to be at the end of the list, right? For any given user. But we don't just have one user, right? It's possible that we were told, okay, this user, we're given some user, but they maybe follow 2 people, right? Maybe the second person that they follow has these tweets, 4, 5, 6. And let's say these are the actual tweet IDs, right? So we know that this is the most recent tweet from the first.
Evan, so you're applying to college right now. What is your opinion on UIUC for CS? What is UIUC? Okay. So I'm guessing University of Illinois. Urbana campaign. Okay, so I'm guessing this is the place they're talking about. I actually don't have an opinion on this because, yeah, I don't know the university enough. But I will say, any university in general is a good place to learn CS. Because if you think about it, even for something, say, like Harvard, if you're in Harvard, if you learn well, you can do well. But even if you're like in a state school, or I don't know if that's the right word, even if you're in a school that isn't Harvard, right? It's just a normal normal college. If you learn well, like for yourself, it doesn't really matter which uni you're at, if that's your goal, If your goal is to learn well, it doesn't matter which uni you're at. You can do it anywhere. So Aryan, you'll be doing your master's in data science. What's your thought on the field of data science? Honestly, I respect it. I respect the people who are able to work with data, right? The thing for me is I lack the drive to data wrangling, to data manipulation. I'm more inclined to build stuff that maybe produces the data or whatever, right? But yeah, I don't really like getting insights, but I like the people who are able to do that because that's something that I can't do. So I respect that out of people who can do data science. But in terms of job opportunities, you can probably become a quant trader or something for a HFT or high frequency trading company. But the chances of you getting that is probably even more difficult than, say, big tech. But I'm not too sure that. But yeah, I haven't looked into it closely. That's a great approach, as you have found out your main aim, what you love to do. Yeah. So, yeah, I like what I do, and I'm sure other people, who are doing data science, love what they're doing as well. And so it's there's a mutual respect for that. There's a level of mutual respect. Because each one of the other doesn't want to do each other's work. You can think about it that way.
First person that they follow, and this is the most recent tweet from the second person that they follow. But these values, we can't just compare the tweet IDs, right? Because that's what we have right now, a list of tweet IDs. So
Yeah,
instead
true.
of just having a list of tweet IDs, how about we also keep track of the time that tweet was posted? So in that case, we won't just have a list of tweet IDs, we'll have a list of pairs, a list of, I'm going to call it count, because that's what we're going to be keeping track of for time, right? We don't actually have a time, we have a count of how many total tweets we have. And we're actually going to start our count at 0, and then we're going to decrement it to -1, then to -2, then to -3, and you're going to see why. It basically has to do with us using a heap, and in Python at least, there's not really a max heap, so we're going to be using a min heap. If you're doing this in Java, by the way, you can just take the count and start at 0 and then increment it to 1, then to 2, then to 3. But in this case, I'm going to be decrementing it from 1 to -1 to -2, and it'll work out for us. This count isn't the most important part of this function. Okay, so once again, let's say we're trying to run get newsfeed for some particular user. Now, first thing we want for that user is who do they follow? How can we get that? Well, remember, we have a hash map for that. We can take this user ID and get a hash set of all the people that they follow. And a hash set, in this case, is basically equivalent to a list for us, because we're just going to iterate through all the people that they follow and then get the tweets of those people, right? So for each followee ID, that's a person, right? That's a user. How do we get their list of tweets? Well, conveniently, we have a second hash map for that. We can take that followee ID and then convert it into a list of their count and tweets, right? And that count is really just going to be used to figure out what tweet occurred most recently. So suppose we did all that work, right? We took some user and then got a list of all the people that they follow and their particular tweets. Let me just draw out some example for that. Let's say we have 1, 3, 5. And let's say these are the counts, right? Because we know that that list is actually going to have a pair of values, count and tweet ID. We do care about the tweet ID as well, because that's what we're going to be returning. Remember, we're returning a list of the tweet IDs that occurred most recently, the 10 tweets that occurred most recently. And if there aren't 10, let's say there's only 8 tweets from all the people that they follow, then we occur however many we have, right? We don't go over 10, but if there's less than 10, then we'll return however many we have. But in this case, let's say there are less than 10. Let's say we have 2, 4, and then for the other one, let's say we have 6, 7. So not only do we want at most 10 tweets, but they need to actually be ordered from most recent to least recent. So how do we do that? That's really the main portion of this algorithm. And it's basically exactly like merge k sorted lists. The naive way to do this would run in big O of 10 times k, where k is basically the number of people that user follows. And let me tell you why. Because of course, for each, in this case, we have 3, right? Basically, I'm saying k is equal to 3 because we have 3 different lists. If we're trying to get the most recent tweets and order them in that way, of course, we're going to start at the end of each list, right? So we're going to have a pointer for each list. You can call it an index or whatever you want. And we're going to compare all of these, right? Which one occurred most recently? Which one has the smallest value? In this case, 4 is the smallest value. So what are we going to do? Well, we're going to take 4 and add it to our list. I'm kind of running out of space, so let me just create a variable up here. Sorry if it's messy. So result is going to be our list. So we found the first value. It's 4, so we're going to add 4 to that list. And then we're going to take that pointer, which was here, and then decrement it. We're going to shift it to the left. So now it's going to be over here. And then we're basically going to keep repeating this, right? We're going to take the minimum of all of these. And the reason the time complexity is 10 times k is obviously we have k lists to find the minimum between k values. It's a big O of k operation. So that's the naive way to do it. But if you've solved merge k sorted lists before, you know that we don't have to do it in the naive way. The slightly more optimal way to do this is actually to take our frontier of all these lists, basically frontier is all of the pointers, right? Wherever the pointers are, take this, and add it to a data structure called a heap. In our case, we want the min heap because we want the minimum value, right? We want to know which one of these occurred most recently. And actually that reminds me, we remember we were actually going to make these values negative. So sorry if this was confusing. Or remember, we were going to start at 0 and then make all these negatives. So that doesn't really change the problem at all, but it's just how we're going to implement it in the code. If you're using Java, by the way, you don't need to make them negative because Java has a max heap, which you can use, but we will be using a min heap in Python. But the idea is the same, right? We're going to take these values, add them to a heap. In our case, we're going to be using a min heap. And then from this value, and this value, we're going to find the minimum. We're going to do that in log k time. And how many times are we going to do that log k operation? Well, of course, only at most 10 times, right? So the time complexity is 10 times log k. So that's better than 10 times k, which we previously had, right? Well, not quite actually, and that's kind of the dumb part about this. Even if you do use a min heap, it doesn't really change the overall time complexity. Let me tell you why. Because let's say we take each of these k values and we add them to the heap. We can add these values in 2 different ways. We can push each of these values, which would result in k times log k, just to push these values, these k values to the min heap. Or we could run heapify, which would be a big O of k time operation. So that, in addition to our 10 times log k, it makes the overall time complexity still big O of k, which is what we already originally had. So it actually doesn't change the overall time complexity. But the benefit is if we were running this algorithm in a generic case where we didn't have to actually receive 10 different tweets, maybe we had to receive up to n tweets, our algorithm using a heap would be more efficient. So I think I've talked enough about the complexity and how we're actually going to design this. Now it's actually time to implement the solution and code it up. Just to save a bit of time, I'm just going to copy and paste
So
a few
here's
lines
the
of code.
problem. He doesn't explain, or maybe I missed it,
Here, sorry
how the heap is created.
if it's messy. So result is going to be our list, a to-do of all the people that they follow and their particular tweets. Let me just draw out some example for that. Let's say we have 1, 3, 5, and let's say these are the counts, right? Because we know that that list is actually going to have a pair of values, count and tweet ID. We do care about the tweet ID as well, because that's what we're going to be returning. Remember, we're returning a list of the tweet IDs that occurred most recently, the 10 tweets that occurred most recently. And if there aren't 10, let's say there's only 8 tweets from all the people that they follow, then we occur however many we have, right? We don't go over 10, but if there's less than 10, then we'll return however many we have. But in this case, let's say there are less than 10. Let's say we have 2, 4, and then for the other one, let's say we have 6, 7. So not only do we want at most 10 tweets, but they need to actually be ordered from most recent to least recent. So how do we do that? That's really the main portion of this algorithm. And it's basically exactly like merge k sorted lists. The naive way to do this would run in big O of 10 times k, where k is basically the number of people that that user follows. And let me tell you why. Because of course, for each...
Okay. What? So when you have these two heaps, if they're done as heaps, you pop from the heap. You know the top of the heap is going to be 0. Index 0. You know that when you because it's a max heap, you want to return the most recent time for sure. The confusing part is like the negatives and the positives here, but I can get it. When you, I guess, post tweet, that user with that specific tweet ID, that tweet ID gets added to that user's heap. And then when you get the news feed, you just need to compare between each of these user IDs, followers, or followees, or follower, who they follow. This user's followees, and then you would compare out of each of those. Alright, I think I got it then. So let me do this then. So set, this is going to be the set of the users. Yo, I just did something massive. Okay. Self users is a set. Self users is going to be a dictionary. Or we can say a default dict of, okay, so a collection's default dict. Of a set. Okay. And because of that, you're gonna have I guess users followees and users posts. All right, and users posts is a collections of default dict of. Now this is a list, okay. Problem is also I'm using default dict twice, so I might as well from collections import default dict and just remove all instances of collections. Yeah, that's fine, I think. So post tweet. Okay, let's do follow first. And follow is hopefully going to be pretty simple. Users followees is going to equal to follower ID equal to, dot add followee ID. Okay, now is that as simple as it is? It seems that it is. Users followees of follower ID dot remove of followee ID, right? So user set there, that's as simple as it gets. Now the post tweet, self dot users followees is equal user ID. Now instead of appending, we might want to O of log k by doing a heap q heap push this onto this for the count, so some count and tweet ID. Now this count, what is it? Well, we're going to have to keep it here, first initialized to 0, and count has to decrement. Right, so we're decrementing this by 1, and that's what count becomes. So self. We can keep this as after, right? So fine to do this. It doesn't really matter before or after. However, that is an O of k operation, or log k, I mean. And then get newsfeed is the main difficult part, I think. So get newsfeed for, followee in followers in self user followees user ID. Now each of the followees while I is less than 10 and I is equal to 0 and I is plus equal to 1, followee. Now the followee self-users posts followee plus equals the followee 0. 0 being the top of the heap, which is the most recent tweet. If the most recent tweet has a count so we're going to keep the most recent tweet. Most recent, I'll just say. Most recent is man, the most recent person. I guess it's an over an operation. Depending on how many people you follow. And then afterward you'd have to pop. But it's got to be a followee. Could you ever have 0 followees? You could. I guess you also consider you have to print your own, right? So you yourself is a consideration. If that's the case, it's always asserted to be correct. So these user followees, the IDs of each of the followees, plus user ID. So that just includes user ID itself. Now, instead of followee, we'll just call it ID. Because, so user ID, no, we'll call it UID. We'll call it UID. So instead of followee, it's called UID of the first value count. If this value, is greater than the current most, so the most recent self-users posts most recent maybe this has to be a user ID. If it's greater than the most recent, zero, return, no, most recent equals UID. Now problem is, that this could be empty. So if it's not this though, then don't you have a problem? Because you will never check there's a bit of a if condition hell right now. I think I know the way still. So check every user ID. Check every followee plus current user. Check every followee ID plus user ID. So instead of saying the most recent, because it could be empty, right? Could be an empty list. Okay, could be empty list. Now, in the case where it says an empty list, you want to just set a default most recent. And after you got that default most recent, when you are incrementing, you don't necessarily need to increment it up to 10. If there's nothing left, then you have to break out of the loop and just return what you have. At some point you got to break out of the loop. However, like, how can you, because you're popping it off the queue, but then you don't ever add it back. So when you do the next get, is it not a problem? Damn, it's already 40 minutes. Man, alright, fine. Ah, man, I can figure this one out, man. I can figure this one out. The thing is, Alright, let's see how they do the most recent part. So post tweet, the count is 0, tweet map, follow map. Alright, this is what I do as well. So tweet map, append, you append and you don't really heap push. Okay. And in the follow and unfollow, you just have add and remove simply. And this is where we have the main part of the code, which makes the difference. So the result, the min heap, hold on. Are you telling me that you construct a min heap from popping from the right, popping off the stack? Or is it really popping off the stack, or is it just keeping the values there and just popping it off when you need to create the 10? Let's see. If you do that though, why not just compare? Now, let's see. So the self of the follow map user ID, you add the user ID. You just add itself. And then you do followee. So followee ID is this. And then you followee ID in tweet map. Right, if it is in tweet map. So from the last tweet, count tweet ID, follow ID index. So you want to include the followee ID as well as the index -1. Couldn't you just do count and tweet ID? It doesn't matter that you need the others, because I feel like you don't need to use followee ID, right? Looks like you do. You append tweet ID when you pop from the min heap. And if index is greater than 0, count tweet ID is equal to self tweet map. Now, why is the index greater than 0? This index is this is not the way that I would have written this. So using the min heap here is almost as if the maximum value of the min heap is just the number of followee IDs. Now, if it decreases, it will decrease. So what if heap pop has nothing left though? Damn, the way you do that is crazy. I wouldn't have thought of that.
It would be better to call this time, but really it's just counting our number of tweets. So basically we can maintain which tweet was created earlier than another tweet. We're also going to have a tweet map where we map each user to a list of that user's tweets, as well as the count, which is going to be used to figure out which tweet was created earlier.
I guess it would be too inefficient to keep the heap push. And it would be better just to keep a track.
And of course, we want to be able to have a follow map to maintain a user and a set of all the people that they follow. So I'm actually going to implement the follow and unfollow first because they're a lot easier. So for follow, we take our follow map, and for a follower ID, we want to say, okay, this person is now following another person with the followee ID. So with the...
Okay, now, sure, so let's say then you just append this. Instead of really doing a heap push here and just doing the way you intended it to be in an O of 1 operation. Take that away. Okay. Okay, so now okay. So this is going to return the whole list, but you want some index. Index equals len of I mean, it could just be -1. Could be -1. So self, that would just be the very last one. So at the very last one, you would get the count as well as the TID, tweet ID. And you might want to add this to the heap. So some heap though, you're going to say the heap. So this is the PQ, I guess you could say. The priority queue. Of the count, the tweet ID, okay, tweet ID, UID, index. I guess you could say just call it I, right? Just call it I. Now heap pop, heap queue, heap pop from the priority queue to the count, TID, UID, and the index. At some point you're going to heap q dot heap push the next value, UID, to the priority queue, the count, of something, the TID of something, the UID of something, and the I of something. But when you're here, you heap pop, you know what that user ID is. That is going to be -1. You push to the priority queue. So while I is less than 10. All right, now this is, I guess we're going to call it J now. J is equal to 0. And we're just going to say J++. It doesn't matter what the count is, right? But you're going to get a new count and new Twitter ID. From heap, from self.users posts UID I. Which then you would add to create that. But in the meantime, you would add the Twitter ID. Does the count matter? Nope, not anymore. Right, so you would add the TID being the most recent TID. And then the count of the TID, the count and the TID together, self-user posts ID again. The UID is still the same, but I decrements and count is a case. Yeah, so this does still make sense to me. Okay, but what happens when I becomes 0? If priority queue if not priority queue return, I mean I'd break. So it's because no values left to add. So no tweets left to process. Read from. And you just break out and return whatever it is. However, if I is greater than 0, right, if it's greater than 0, so it's 1. The last value is 0, so when it becomes 0, you don't add anymore. Moment of truth. Nope. Oh, I forgot. That has no attribute append. So users followees. Users posts dot append. Huh, I wrote user followees. Add for a set and a list. Oh, true. We'll just union this. And make this a set. Yo, wait. User ID. Int is not iterable. I guess union returns something different. Should it? I don't think it should. Oops, never closed this. Oh, int object not iterable. Hold up. Now, none type object not iterable. Alright, this is going beyond stupidity, I think. Add to a set, man. I guess I'll just add to a set the user ID. Does that hamper with anything? And then I can just afterwards remove the user ID, I guess. Alright, fine. Afterwards, we just remove the user ID. What? Oh. Okay, accepted. Not accepted. Key error of 1. Oh, shit. You want to start competitive programming? Is C++ a good choice? Yes, it is. It's definitely, that's what all the competitive programs use, so for sure, use that. The only reason I'm using Python at the moment is because that's all I care about. I just want to do Leetcode for getting a job, not necessarily for competitive programming. Where to start? I'm learning basics of programming for now. Well, okay. If you're learning the basics, you know, still going with C++ is a good choice, but perhaps you can consider Python as well. I think, you know, Python is easier to learn than C++. Your choice, man. You can think of it as, you know, you learn Python now, you might learn C++ later, if you want to think about it that way. Now, why does this actually cause any difference? Oh no. So how do you deal with that? If I is greater than 0, I is equal to 0. Let's have a look at the running submission again. Okay, so running that submission meant key error 1 doesn't exist in the following IDs anymore. Am I doing the right thing? This is a key error though. Follower ID, remove followee ID. What's happening in the unfollow step? What's you do, bruh? Trying to do design Twitter feed, except this is taking too long. It's taking way too long. By the way, this is me after looking at the solutions already. So I'm trying to still design it from my thinking. At least I know this part is right. You append the tweet ID, yes. And then you're saying the count and the TID. I mean, I'm asserting that it can't ever be zero. I mean, less than 0 already. So that's fine where it is right now, right? Yes. And you hit push. J is less than 10, J++. Otherwise you break. So if not PQ, you break. I guess you should check that only when here. Do you work at a FANG? No, I don't. Should I buy an online course or can self-learn from YouTube? You can definitely learn from YouTube. Don't buy any courses. If you wanna learn about Python or C++, there's always online resources you can find, like W3 Schools or Geeks for Geeks. Their documentation on that stuff is pretty detailed already. I would say just use that. So what tech stack are you working with? So not working at a FANG, but I am using like a specific tech stack for my personal projects, which is a unique one in the sense that it's Fast API, React, Node, and Postgres DB. So, hello Zahib, good morning. Hopefully, I think it's good morning to you, I think. What am I missing? Gotta figure this out so bad. Oh, shoot. That's right. I set I to -1 originally here. And it could be len of self. Yeah, of the user ID. Users, posts, UID -1. God damn it! What's still going wrong? Yeah, it probably is this. Why is this hard, man? There's something wrong with mine so bad. It's just a small error. I guess. Yo, how is this still messed up? Case 1 is correct. I suppose len of res. Yeah, that's is still good, to be honest, instead of doing that. Surely. That's so crazy. Okay. I'm just gonna do this then. Only difference. Oh, turns out to be not the only difference. And follow is correct. Okay. If followee ID in self uses follower ID, follow map uses followee ID, dot remove followee ID. Yeah. Still sus. Still very sus. Like it's working for one, but it doesn't work for two. And I can't point why. Bro, are you from Japan? No, I'm not. I'm from... I was born in Australia, but my ethnicity is Chinese. So... Fuck me, man. What is the problem here? Because I can't not figure this out now, given how much time I've spent. Now, why is this heap push -1? Well, that was it. Okay. Well, sure. We'll take it. Got the main concepts though. Use a heap to keep track of the top of the list and use the heap values or heap nodes by use the heap nodes attributes that you can come up with to help with the data structures you are using. Now, I think that's okay, but it's still quite a lot of typing, alacrity, Leetcode, $355 design tour. .py. Yeah, man. It's done, but am I happy with it? Yeah, somewhat. Because it did take more time than I really would have liked. Complete, but got stuck on little bugs. I watched the video solution before attempting this question myself. This question is similar to merge k-sorted lists. This question is apparently similar to merge k-sorted lists. Merge k-sorted lists. Now this should be the problem. Now, have I done this before? Solutions, submissions, I have. Okay, now so should have a merge k-sorted lists. Okay, and so that's a hard problem apparently. Might be worth a review on this question specifically. But regardless, we paste from. Nope. Damn, bruh. Is that what's up with the beats 100%? Yeah, what's up with the beats 100% here? Oh wait, I wanted to rerun. I'm guessing they either increase their compute like a lot, or there's something else going on. O of 1? There's something else going on, man. Okay, we can close it. So that's finally done. Took an hour probably, and a bit more. We should read up on some of these assignment practices. But I'm gonna have dinner soon. Oh, we'll watch out. Let's definitely look at some of these problems here. So will not be examined perfect. They do not have authentication functionality by themselves, however they can be used as a compress function to construct MAC. Well-known example is CBC MAC. Zengilai, you're so like good at— what is you? Who is you? You're really good. It's not loading. He is my tutor. Yeah, he is my tutor. He's really good. He is one of the best tutors that I've had for any subject. He's really good. So modes of operation, I'm gonna just review that right now. All right, modes of operation. Now, modes of operation. Okay, what is the consequence of using electronic code block mode? What does 3DES prevent? I don't know, authentication attacks? Meet in the middle attacks. Well, that's ambiguous for me. Meet in the middle, the use of double DES results in a mapping that is not equivalent to a single DES encryption. The meet in the middle attack algorithm will attack the scheme and does not depend on any particular property of DES, but will work against any block encryption cipher. I'm gonna stand. Man, according to me, if I sit alone, code like this long, it feels boring. At least streaming makes it a little fun. That's right, man. You are not wrong in that respect at all. So, that's why I do it. Let's see. So the consequence of using ECB, P1 will be the same as C2, which means P1 and P2 are same. Right, the ciphertext 1 will be which means P1 and P2 will be the same. That is a little bit sus as well of an explanation. If P1 and P2 are the same, then C1 and C2 are the same, given the same key. Yeah. So, yeah, I agree with that. I agree with that sentiment. Coding without music is equivalent to browsing in Internet Explorer with 2G internet. I mean, let's just say, how is that equivalent? Why? Because it's dry? I guess, wait, yeah, I get you now. Coding without music is dry because it's equivalent to browsing in Internet Explorer with 2G internet, which is also dry, or boring in a sense. You could make that comparison, you could. Do you know George Hotz? No, I don't. Who is George Hotz? Hello, Fala. Thanks for saying hi. Right, security hacker and software engineer. He's known for developing iOS jailbreaks. Fair enough. Alright. Some of his good work I've probably used in the past then. Not bad. Have I seen this? I've definitely seen this in my feed, actually. On YouTube. Fair enough. So it kind of does like streams as well. Well, now I know. Now I know. Now I know. Okay, so ECB means that when P1 and P2 are the same, C1 and C2 will be the same. So why is the initialization vector needed in the cipher block chaining? It's because that's for the next block to be created, we need the previous block's ciphertext. Now, in the first block, that previous block ciphertext, there is no previous block. So that's why you need an initialization vector. Now, looking at what that looks like, ooh, it's XORed before. I think I drew one with XORed after in my solutions. Never mind, I never did that. Okay, but that means that it goes from here, right, all the way up and across. Which is fine, like that's still CBC. Here. You got some key passing through an encrypt function. Now I never really put that there, so this is some key of the encrypt function. Now decrypt would be interesting. Decrypt is key with some ciphertext and the initialization vector on the XOR. Now that is, like, I can derive the decryption function from the encryption scheme, so it's fine. Hello Slayer, welcome as well. So cool, cipher feedback mode. It's not really something I gotta look at now. Okay, so that's fine. IV is private, chosen. Yeah, draw. I guess, you know, one thing is draw CBC and the encryption and decryption of CBC. Now that is just this this link. So that's one way to think about doing things. Now, meet in the middle attack works on any block encryption cipher. Is this true or false? It should be true. Hello, Victor. Well, everyone's saying hi. So how come we're talking about meet in the middle attacks now? Because a double DES results in a mapping that is not equivalent to a single DES encryption. The meet in the middle attack algorithm will attack this scheme and does not depend on any particular property of DES, but will work against... Okay, it does not depend on any particular property of DES, but will work against any block encryption cipher. Yeah, triple DES, I don't think it's likely that we'll talk about triple DES, so I'm fine. Oh, wait, am I fine just thinking about it? We do have lots of information here. And what are the modes of operation? You know, that's all mentioned here that we could use. MMA, I'm guessing you mean meet. Yeah, meet in the middle attacks. Yeah, as opposed to man in the middle. So I think that's a better acronym MMA. Why don't we use that in this textbook, man? Is one of the reasons why data encryption standard was replaced with the triple DES and not double DES. An attacker can use a meet-in-the-middle attack to brute force double DES with 257 operations and 256 space. Right. Making it only a small improvement over DES. Triple DES uses a triple length key and is also vulnerable to a meet-in-the-middle attack in 256 space and 2112 operations, but in consideration, but is considered secure due to the size of the key space. So that's at a high level. And we have meet in the middle, and we have the actual page talking about it. Double DES. Triple DES with 2 keys. One of the most widely used symmetric ciphers have been largely replaced by strong encryption schemes. So DES is from a symmetric cipher. Yeah. That's something to remember. So DS is a symmetric cipher. Double DES and triple DES. Maybe I'll write it here. Problem is, you got to look at more at the symmetric ciphers. I will have to review all of these concepts in detail. You know, I looked at the exam revision material. I need to remember modes of operations still. So what are the modes of operations? Let's go back to that page. So I close this, close that, keep that open, keep this open. Now we can close it. But this is where we should see some CBC stuff. Right, I don't need to worry about this. Advantages of CTR. So, right, here we go. So how many modes of operations? There are 5. What are they? Each of these. You don't know what is happening, but seems fun. It's, yeah, seems fun. Block cipher modes of ops. So electronic code block. I bet like someone in the exam, if they are to write like the words, one person will probably write electric code block. Code block. Also, code book. The electronic code book is what it's called. Each block of plain text bit is encoded independently using the same key. Now that means you can easily find patterns, and that would be an issue. So then you have a cipher block chaining, which makes it better by using the previous encrypted value to as the key input for the next block. And so the input to the encryption algorithm is the XOR of the next block of the next block of plain text and the preceding block of ciphertext. So encrypt is the XOR of the plain text is the XOR of the next block of plain text and the preceding block of ciphertext. Yes, I agree to that statement. Probably an odd compliment with your sound face. Man, thanks man. Nah, it's not odd. We got a good mic. We got a good mic right here. You could say it does all the work. Now that's fine, like ECB and CBC, I can remember those pretty easily now, but the cipher feedback, like I don't remember exactly what it is, but it says input is processed S bits at a time. Preceding ciphertext is used as input to the encryption algorithm to produce pseudo-random output, which is XORed with plaintext to produce the next unit of ciphertext. Okay, I think I know kind of, I think I can like draw this out just from this description, which I will just temporarily here on the side. So we're looking at, so input is processed S bits at a time, right? S bits at a time. Preceding ciphertext is used as input into the encryption algorithm. So you might have some, so this is the encryption algorithm. You have some previous ciphertext, or we'll call this an initialization vector. You got the output and you XOR with some plain text to get the next unit of ciphertext. So then, so there's no this. XOR again to get this. And this is where the P comes in, right? I think that's how it looks. This is cipher feedback mode. So is this in the right understanding, right direction of understanding? Encrypt. The key. Okay, so there's always a key to the encryption function anyway. There is always a key to the encryption function. This is still here. But you have, yeah, some P that you XOR with to get C. Right. Now shifting the register here is a little bit questionable. So B minus S bits and S. So it's just like you have this queue of bits that incrementally get deleted. It's like a queue of bits that you just have. Now, going the opposite direction, sure, you have an initialization vector, some k, some output, and some plain text from the ciphertext. Yeah, that's just the property of the XOR that you're just displaying there, so that's good. All right. Cipher feedback mode, I remember, and I remember it better now. So just because it's, yeah, it makes sense. It makes sense. I can delete then what I drew here. Okay, now what we have, I'll make this since we're going to be drawing, make this. Okay. I'll make it slightly bigger. Okay, so output feedback similar to cipher feedback, except, so what makes it cipher feedback and what makes it output feedback? That's something to remember. So I'm about to eat in like 5 minutes, but yeah, so give me 5 minutes. I mean, I'm gonna be done in 5 minutes just to have dinner, but let's see, should I be back? Should I be back for more? 7:30, I can, yeah. I want to sleep well though tonight. I want to wind down at around 8. That's the thing. So if I wind down around 8, it means I kind of have to end the stream earlier. You know, it has been how long? Almost 2 hours, which is good. If I go for another hour, I could do that. So here's the thing, I'll have dinner, but I'll come back and just do a little bit more. And then we'll call it a day at most likely 8. So right now it's 7. But, you know, there's only so much we can do a little bit more. So I don't know if it's worth keeping the stream on. That's the thing. Okay. But I will see, so the, yeah, you know what? I might go to 8:30. I might go to 8:30. All right, so I'll keep the stream on. Now, so finally, output feedback. Similar to cipher feedback, except that the input to the encryption algorithm is the preceding encryption output. And full blocks are used. Is that not what you do here? Initialization vector. Oh. Output feedback or cipher feedback. I see, that's what makes the difference. You know, output feedback, output of encryption function. Encryption output, that keyword, encryption output. Okay, and a counter. So each block of plain text is XORed with an encrypted counter, an encrypted counter. The counter is incremented for each subsequent block. Okay. So when decrypting, it's going to be interesting the ciphertext XORed with the output to get the plain text. You got to know the nonce to begin with. You got to know the key to begin with. I see. Now, what about the counter? Right, counter 1, counter 2 to counter n. But it almost looks like... it almost looks like... It almost looks like a combination of... not really. Yeah, kind of. No. Okay. Yeah, I mean, it's an XOR of the... You're doing the XOR after the encryption. There's a few properties that are variating, you know, like, you know, the XOR coming before or after. It comes before in CBC, it comes after in OFB, CFB, so cipher feedback, output feedback, and counter feedback, or just counter mode, sorry. Problem is stream oriented. Block oriented. So I guess what makes it block or stream oriented is the fact that for it to be block oriented, you need the previous block to continue the encryption. But if it's stream oriented, then you just need the encryption and not the block. Okay, so that's kind of like a key detail of the modes of operations. A key detail to remember about the modes of operations is that ECB, Electronic Code Book, and CBC, cipher blockchaining, are both block-oriented ops because F, so OFB, so output feedback, and cipher feedback, and counter modes are all stream oriented, meaning they only require the output of the algorithm, encryption algorithm, to work. The decryption block oriented means needs the actual blocks of content versus stream oriented where the blocks of content do not need to be used and could be faster. Hello Odmers or OD misses, I can't tell which. But good morning, good morning. To me it'll be good evening because it's 7. But I am about to go eat now, so I'm gonna just put on some lo-fi music, and then I'll be back around 30 minutes, where I'll continue for another 50 minutes before we call it a night. Alright, I'll see you guys in a bit. I am back. That was more like a 50-minute lunch, to be honest. And hello, and VimDev. Don't know how long you've been there for. Now, I'll just spend 30 minutes here. Just for the rest of the stream, around 30 minutes, so we'll time that. Just to do some more study here. So let me review from what I just said before on the modes of operations. Now, there are 5 modes of operations. We have the electronic code book, which is going to be given the same plaintext, the same ciphertext output. Now, the CBC makes this better, which is the cipher blockchaining, makes it better by using the previous cipher into the next cipher and into the next cipher block. And you know, both of these are block ciphers, and yep. The problem is why is this first one a block cipher? Because when you do an encryption and then you use a key using the encrypt function to get the ciphertext output, you don't have an XOR anywhere there. So that's confusing. No, it's fine. And if we go to OFB is the output feedback, and we also have the cipher feedback. The cipher feedback is once you've done the XOR. No, that's not. It's once you get the cipher. Wait, is it really once you get the cipher? Now we gotta check that back. It's once you get the counter feedback, that's fine. It is when you get the cipher. So you take the cipher, put it in the next, and then you continue all the output. But why is it a stream cipher? Why is it considered a stream cipher and not a block cipher? You know, that's kind of confusing. So counter is a block oriented. Cipher blockchaining is block oriented. Okay, well, I was wrong to what I said before. It's fine. It's alright. So that is cipher blockchaining. The thing I should check up on is yeah, some more of these. So ElGamal encryption is one of the main things that I need to keep on top of, so I'm going to do that. The problem is also all of these. One lesson from TOP, Leetcode, scheduler development. Yep. Yeah, this is something I gotta do. Okay, for now let's review the ElGamal encryption. Oh, hello guys. So Kevin, Yosa, do you have the best source to learn TypeScript? Honestly, I would say the Odin project. How much question of DSA should we do in a day, and what do you do? So I do just one question of Leetcode, one Leetcode question a day. That's my objective because I want to learn it well. So, you know, each question that I have been doing, it has taken me about an hour each time to do it in its entirety. Maybe it could be done in a better way, but yeah, it takes me an hour for each question, roughly. And you have Windows. What's this to-do app? That to-do app just before was called Things 3, and unfortunately it's only an Apple app, unfortunately. So, you know, there's a Mac app, there's an iPad app, there's an iPhone app. Problem is you have to also buy them separately, so yeah, I bought them separately, and I bought them all for a total of $130, I think, was roughly around there. So is it worth it? I don't know. I really don't know if it was actually worth it, to be honest. And so I'm kind of trying to make it worth it by building my own app as well. You know, having the experience of this app, which costs some money. You know. That's kind of what I'm doing. I will say I need to just grab something. You think it's worth? Alright. Let's hope, man. I really do hope. Alright. I just said hi to someone on the Discord just now who joined recently. Okay. Now, the ElGamal protocol, this is where we're going to have issues. We're going to have to revisit ElGamal in its entirety. The ElGamal encryption, alright, we don't actually have proper notes for this at all. Now what is this? This is like written notes. Yeah, this is written notes for... Why is this site unreachable? It would just be a link, right, to a YouTube video. Yeah, so it's just a YouTube video. Should just make this apparent, I guess, instead of calling it site unreachable. YouTube. Okay, alright. ElGamal. The thing is, I need ElGamal. I need to open this to just learn about it. So, here's the thing. Do I want to move this out into a separate window? Have this one on the side? Yes. Yes. Okay. And I'll maybe just make this larger. That one's smaller. I think that's fine. Okay. Now, in the next 21 minutes, ideally, I should be able to just understand all of this. So, a cyclic group. Alright, so the cyclic group is example of a cyclic group, mod P is 11. So the generator of 2 and order or size of G is 10. Now it's 10 because there's 10 different possibilities, and the generator means you're timesing 2 every time. So every time you times 2 mod some prime, prime being in this case 11, so p is equal to 11. What power of 2 is equal to 3? Well, that is the problem. That is the... Is it the discrete logarithm problem? Yes, I think it is. I think it's the discrete logarithm problem. I think that's why we call it d-log, right? So, because you can't find it unless you just brute force. And the thing is, so what power of 2 is 3? Well, you would have to say 2 to the power of 1 is 2. Well, no, that's not it. 2 to the power of 2 is 4. 2 to the power of 3 is 8. 2 to the power of 4 is 16. Mod 11 is 5. That's why we get the answer of 5. But that's not 3. And 2 to the 5 is... yeah, 32. 32 minus 22 is 10. That's why we've got 10 here. And 2 to the power of 6, 9, blah, blah, blah. It keeps on going. And yeah, right, so we find eventually 2 to the power of 8 is 3, and that's what makes a cyclic group. That's what makes this a discrete logarithm problem, using this cyclic group. Okay. Now, I got two suitcases. Two new suitcases. Bought with my own money. They were 50% off. And they're pretty good quality. I like to buy quality stuff. I don't know, I just wanted to tell you guys. Apparently it says lifetime warranty. Obviously lifetime warranty of the company. But I digress. It's like a lanyard. Almost. I could wear this if it fit over my head. It's like a lanyard. Okay, Zn integers mod n. N is a positive integer under multiplication. P is a prime number under multiplication. Residues of polynomial over Zp. So residues of polynomial is a good question. Elliptic curves over Zp is another good question. Some examples of cyclic groups present inside a bigger groups. Sure. Order of cyclic groups. What is the maximum size of cyclic groups? Cyclic subgroups. Choosing a generator. Now discrete log problem. For P11 the problem is trivial. Brute force table here. For large P, however, generic algorithms exist which beat brute force. Baby step, giant step. Follows row. Specific algorithms work even better when working mod P index calculus. P must be greater than 1024. The industry has largely moved to elliptic curves. Yep. Yeah, same discrete log problem. So the Diffie-Hellman protocol. This is the recap. So public parameters, generator, order of the cyclic group. P-1 and prime. Cool. Diffie-Hellman problem, computational Diffie-Hellman, or decisional Diffie-Hellman. So given PG, GA, GB, can you compute GAB? Given a hash, is H equal to GAB? Bit in an algorithm might exist that solves, but not DLP. Discrete logarithm problem. ElGamal crypto system invented by ElGamal, closely related to Diffie-Hellman. Simple observation, do Alice Bob both need to be online for Diffie-Hellman? Now, what if one party publishes a share in advance? Is it safe to reuse a share across multiple exchanges? Okay, so that's the question, right? So the whole motive of ElGamal is, do Alice and Bob both need to be online for Diffie-Hellman? Okay, so ElGamal setup, we first use the notations as the Scrolling's textbook. Assume that one party in the Diffie-Hellman is fixed in advance. Assume computations mod Q. Q is prime. A, generator of the group. Alice generates a key pair in advance. Bob somehow learns this in advance, as we discussed last lecture. Choose a random K and compute this, yada yada, yada yada. Why random keys are important. Modern study in X3DH. Okay. Okay. So ElGamal variant of Diffie-Hellman. Sure. Now, so those are all the steps required. Choose a random k, compute a, k, q. Yeah, but assume computation mod q, q is a prime, a is a generator group. Okay, choose random k. Right, man. Right, alright. Let me sit down. Let me sit down for this. This is gonna mind boggle me a little bit. Ugh. Prepare. Prepare. Okay. Let's go. Alright, 6 minutes. We will use the notations as installings. Assume that one party in the Diffie-Hellman protocol is fixed in advance. Assume computations mod q. So q is a prime, a is a generator group. Alice generates her key pairs in advance. So it chooses her secret key XA, computes a public key YA. So that's pretty simple, right? Public key YA is just equal to that. Now Bob somehow learns this in advance as we discussed last lecture. So learns what in advance? Alice's secret key or Alice's public key. Alright. Bob chooses random k, sends an AK mod q to Alice, so this is Bob's public key. Using Alice's public key, he computes YAK, which is equal to AKXA. Encrypt the message for Alice. Encrypt the message for Alice. encrypt the message by timesing the message by YA. K. YAK. Now using her private key XA, we can times AK. AK. So this is, yep, Bob's. So this is, the shared secret is that, perhaps, that they can use to times yeah, I see. You can decrypt the message, which equals to ciphertext divided by AKXA. Now simply that's pretty simple. So, given a generator A and prime Q, both Alice and Bob can pick a XA and XB such that we can get Y A equal to XA, sorry, A times A to the power of XA mod Q, and similar for B, for YB. We can encrypt the message with C equals to M times Y times Y A. Right, I think that's true, I think. So this is YB. No, you encrypt with YA times B. And then you would decrypt with okay, like I understood that. Now ElGamal in more detail. No, we're gonna just pause this because we know we're done. But ElGamal in more detail. Let's try and do a little more detail here. Another user, Bob, e.g. Bob, can encrypt a message to send to Alice by computing the steps below. Represent message M in range, choose random integer k with 1 less than equal to k, less than equal to q minus 1, compute one time key. This is a key. Yes, it is. Is it? Yes. Encrypt message M as part of integer. C1, C2. Pair of integers. Key times M and the public key of Bob, so the public key of Bob and the K of M, the encrypted message. The encrypted message, alright, so Alice then performs decryption as follows. Recovers the key by literally doing that, and compute M by literally doing the inverse with the key. What if Bob reuses K for multiple messages? If Bob reuses K for multiple messages, C1 is the same, C2 you could have problems with seeing patterns. Okay. Like, I get the ElGamal crypto system now. Damn. I mean, that wasn't that hard. That wasn't that hard there to understand. I will say. What are the two pairs in the ElGamal crypto system? What are the two pairs in the ElGamal? The key and the that's easy to understand actually now. Okay guys, I think we're gonna call it a day. I think we'll call it a day for now. I think we spent quite a lot of time. Let's see, so around 2 hours plus another 30, so 2 hours and 30 minutes. That's I mean, that's pretty good today for me, I'd say. Despite not spending the whole day on it, you know, it's still a good review on both ElGamal and the modes of computation. Sorry, modes of encryption? Yeah, modes of encryption. Alright. Let's just plan our day for tomorrow before we fully log out, clock out. So here's the thing, right? So problem is I did some of what I needed to do, but there was a lot that was left untouched. So all of this is going to be moved to another day. The problem is these will be also moved to tomorrow, and we might need to reorganize these, put this on top, put these second from the top. This would probably be down here. The problem is actually it's probably down here. So the rest of the exam paper questions, yeah, that's something I could do just to finish understanding everything. So that should take hopefully up until lunch, I reckon, since if we're doing Leetcode as well, and then do math extension questions for mid-sem break. I will do, because I don't know anything about polynomial rings at the moment. So next thing for me to understand is learn about, you know, practice the polynomial rings. Right now I know which from tutorial, I think it was 11, so I'm gonna try that from tutorial 11, and we do lunch and then math extension questions for mid-sem. That will be after lunch. Most likely here I will do a gym session because I need to go to the gym. Scheduler development we will do later in the day. I think, you know, can I do any of these CV tasks that day? It would be cool if I did one, just to catch up. We'll do that. We'll say one just to catch up. The others will move to the other day. We'll keep on just shifting it a bit. Photography security exam. Okay. Let's try and do this, man. Alright, we'll call it a day. So this is what's going to be on plan for tomorrow, and we'll continue our days then. Alright. I'll catch you guys now. Have a good rest of your days. Some of you are in the morning, so you'll know that I'll be asleep. Oh, alright. Catches. Peace.